All right. In this video, we're going to kick it up a notch or two. And instead of just talking about one-step equations, we are going to talk about multi-step equations. Equations with, multiple steps. We got this. We can do it. It's not that big a deal. Probably this is going to be a little bit of a review from pre-algebra. If not, that's okay. We'll get it done. We're going to do a few just regular examples, and then we're going to look at a couple of word problems, and then we're going to be done. Let's take care of this. All right. Now, oops, I need that one. And that can go away. All right. So, let's start with the example 11x minus 4 equals 29. So we look what's attached, how's it attached, and we do the opposite to get rid of. Of course, we have that little half step of cleanup. We're going to look at that a lot in the next unit. Most of these, there's not going to be much cleanup. So let's dive in and make this happen. So what's attached to the x? Now we've got two things attached to the variable this time instead of just the one. And that's important because we got to decide which one to get rid of. Now, you can get rid of the 11, which is multiplied, so we divide to get rid of it, or you can get rid of the 4, which is subtracted, so you'd add to get rid of it. You can do it either way. Now, I'm going to strongly recommend on these that you get rid of the addition and subtraction first, because if you will do that, you will deal with less fractions. So we're going to get rid of the addition and subtraction first. So this 4 is subtracted, so to get rid of it, we're going to add 4 to both sides. So plus 4 over here, and then plus 4 over there, right? Those ones cancel out, leaving us with just 11x. And then 29 plus 4 is 33. Oh, the astute among you may have already figured out what the final answer is going to be, because the last thing we're going to do here is we're going to divide both sides by 11. Those 11s cancel out, leaving us with x equals 3. Again, I need your work to look like this work, because it needs to be neat and organized and orderly and all of those things, right? Because we don't want to, because we'll make less mistakes that way. All right, let's look at another one, then we'll dive into a couple word problems. So we've got a plus 7 all over 8 equals 5. I'm going to move that over. I think I didn't quite give myself enough space because of what we're going to have to do first. All right. So what are we going to get rid of first? Now, I know I said get rid of the addition subtraction first. And that's true right over here. But really, on this one, we can't get to that plus 7 because that plus 7 is being attacked by this entire fraction bar right there. And so what we really have to do, because this 8 is divided into everything, is we've got to get rid of this 8 first. Now, this 8 is underneath the fraction. Now, hopefully you've learned that fractions are the same as dividing, right? So this 8 is divided into all the rest of it. So what's the opposite of dividing? Multiplication. So we're going to multiply 8 on both sides. Going to multiply 8 over here, and then we're going to multiply 8 over there. Those two 8s cancel out, leaving us with a plus 7 equals, what's 5 times 8? 5 times 8 is 40. Easy peasy lemon squeezy. How do we get rid of this 7? Well, it's added, so we're going to subtract to get rid of it. So minus 7, those two cancel out, leaving us with just a equals, what's 40 minus 7? Well, it's 33. Blapo. All right, let's take a look at a couple of word problems. let's start with this guy. This one's going to be kind of a translate English to equation, then solve the thing, right? Kind of like we did a couple of lessons ago, but this time we're going to actually solve the equation. So we have Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses $25 gift certificate, the total cost before taxes is $185. What was the original price of the skis? Write an equation for the problem, then solve the equation. Now, it's important to note that in order to do this problem here, the writing of the equation is just as important as solving the problem. I know it'll be tempting for some of you to just be like, okay, well, it's this, so we've got to multiply and divide and whatever else. Don't do that. If you are still in the bad habit of doing that, you have got to quit it because the problems only get more and more complicated. And so make sure you actually write an equation and then solve it. All right? All right. So Hiroshi buy a pair of water skis that are on sale for 2/3 of the original price. So 2/3 of the original price. Original price O. I don't know if I'll really want to use O, but I'll make sure to put a curly Q so it's clearly an O and not a 0. That's what we're going to roll with anyway. Might want to use an X on this one if your O's are looking awfully 0-like. 2/3 of the original price. Okay, so after he's buying it for that. Then he uses a $25 gift certificate, card, whatever. The total cost before taxes is $185. So what he is paying is $185. So 2/3 of the original price minus the $25 gift card equals what he pays of $185, right? That sound right to you guys? Yes? No? Maybe? I hope so. All right. So let's take a look at this and let's see if we can solve the thing. All right. What's attached to the O? 2/3 is, and the minus 25. Now, this one, since that division, multiplication isn't on everything, we're going to go ahead and take care of addition subtraction first, just like I said before. So this 25 is subtracted from the O. So to get rid of it, we're going to add 25. If we got to do it to that side, we're going to do it to this other side over here. So plus 25. Those ones cancel out, leaving us with 2/3 of O equals, what is that? That's 100 plus 110. 210. 210. Does that match the notes? Matches the notes. We got this. We are prepared. We can do this plan. All right. This 2/3 is multiplied. Now, we looked at this in a unit previously. If I remember when I'm uploading this, which one it is, I'll put the link to that in the iCard. If not, you can go back through the lessons and find it. Hopefully, you've been watching these more or less in order because they kind of string together. So this 2/3 is multiplied times the O. To get rid of it, we divide. Now, to divide fractions, we multiply by the reciprocal, right? So we're going to multiply 3/2 on both sides. Those 3's cancel out, the 2's cancel out, leaving us with just O for the original price. And then, let's see, 210, and we end up with an answer of 315. Now, it's important that when we're doing a word problem, your answer pretty much always has units. The answer is part wrong if we don't include the units. So what is the units of this? Well, it is dollars, right? $315. Easy peasy, lemon squeezy, no big deal. Let's do one more problem. This one is going to be kind of a really classic problem type that you see in basically every math book ever written. And so we want to make sure we're good to go on these. You'll even potentially see this in a college algebra course as well. So we're going to find 3 consecutive odd integers with a sum of -51. Now, the consecutive integers bit. That guy right there. This is what makes this problem unique. So what does consecutive mean? Consecutive means in a row, right? So if we were finding consecutive just integers, period, and this odd wasn't there, then if we had one integer and we called it n, to get to the next consecutive integer, it would be n plus 1. So like say our integer was 5. Then to get to the next one would be 5 plus 1, which would be 6. And then to get to the next one, it would be n plus 2. N plus 1 plus 1, right? Which would be, in this case, 7. Now, it is not the case that this odd is not there. It is there. And so what does consecutive odd integers? Well, let's kind of think through it with an example of what's going on here. So if we have an odd integer, pick an odd number. I'm waiting. Oh, okay. I guess I can't hear you. 3. It's a great odd integer. Sounds wonderful. To get to the next odd integer, which would be 5, I wouldn't add 1. I would add 2, right? And then to get to the next odd integer, which would be 7, I wouldn't add 2. I would add 4. So if the first odd integer is n, then the next one would be n plus 2. And then the next one would be n plus 4. Okay, so that's the kind of information and basics that we're going with right here. No big deal, right? So how do we get an equation here? So we're going to find 3 consecutive odd integers with a sum. Sum is a key word there. What does sum mean? Sum means addition, right? So we're going to add up all of these consecutive integers, and their sum is negative 51. So our equation would be n plus n plus 2 plus n plus 4 equals negative 51. How can it be negative? Integers. Remember, integers are negatives. Positive and negative whole numbers. You got this. You can do it. All right. So that's how we're going to end up with a negative. So there's our equation. Now, what are we going to do with that? Well, it's not going to be that big a deal at all. What we are going to do is we're going to first start by combining. We're going to combine them like terms. We're going to combine some like terms. So this is that step 0.5, right? Where we're doing some cleanup. So we've got a like term right here, there, and there. And then these two are also alike, right? So n plus n plus n. Remember, if there's no number there, there's implied ones on all of these. So 1 plus 1 plus 1 is, of course, 3. So we've got 3n. And then 2 plus 4 is 6. So 3n plus 6 equals negative 51. So now we're really on just a 2-step equation. It's going to be easy peasy, lemon squeezy. We've got multiplication and addition. The multiplication is not applied to everything, and so we're going to do addition subtraction first. So the 6 is added. To get rid of it, we're going to subtract 6 from both sides. Subtract 6 from both sides. Now this right here is a red flag. I'm going to point this out, that this is a place that you could easily make a mistake. I could absolutely see that happening, and I want to make sure that you see that this is, sorry, I got distracted. Yeah, okay, we're good. Sorry, you beautiful people, you. We've got 2 negatives here. So negative 51 minus 6. The signs are the same, so we add and keep the sign. It would be really tempting, and I've seen this mistake happen over and over and over again, to write an answer of like negative 45 or something, right? That's not what we're doing here. They're both negative, so we're adding and keeping the sign. And I know it sounds like I'm really making a huge deal about this, But this is a really common mistake and an easy one to do. Those negatives will get you in trouble. So watch out for those and don't let them get out of hand. All right? So negative 51 minus 6 is actually negative 57, right? Negative 57. We're going to bring down the 3 in because we hadn't touched it. And then what do we got to do next? We got to divide off that 3 because it's multiplying. Divide by 3, divide by 3. So n equals negative, and if you do 57 divided by 3, it is negative 19. Right? Now, you'd be tempted to just circle that and move on with your life, but we're not quite finished because we want to have all 3 consecutive odd integers. So the full answer would be negative 19, negative 17, negative 15. Remember that negatives, as we get higher, the numbers go lower, right, until we get to 0, and then we flip around to positive. That's it. No big deal. Thank you guys for watching. If you're one of my students, do your homework. I'll see you in class and all of those things. If you are joining us just on YouTube, thanks for joining us. We are offering this entire Algebra 1 course for free, the lecture portion at least. It helps us out if you give us a like and a thumbs up and a whatever the heck good. I'll leave it to your imagination. If you want to see what else we're doing, you can go to emberlearninglabs.com. That link is in the description. I don't know where my words are going today. Have a great day. Bye-bye.